Okay, so today, what we're going to talk about today is how to solve log equations, all right? So in example 1a, you could guess and check, but there's got to be an easier way. Now, in this particular problem, you can do this in one of two ways. The way I see it right off the bat is I know 125 can be a 5. 125 can be a 5. It can be 5 cubed. This particular problem is not too bad because you can make them have the same base. So if I make it 5 to the 2x equals 5 to the third, because 5 times 5 times 5 is 5 cubed, then technically, and of course you can't really do it mathematically, but you can really just look at the exponents because you get 5 to something, 5 to something. So you're not really supposed to cross out the 5's, but we will because it just makes common sense that these two would have to be equal. If you're going to make 5 to the 2x equals 5 to 3, so you get 2x equals 3, divide, and you get x equals 3 halves. Okay, that's easy. You could also do this problem a little bit differently. You can take the log of both sides, but this particular problem like this, that's the easiest way to do it, okay? All right, b. Let's take a look at b. Now, you cannot in b make them the same base. That's a 3. That's a 7. So this one we're going to have to do differently. Now, one of the things we've learned is this log rule. I'm going to rewrite this log rule up here. We had log of base b to say x to the p. Okay, I'm going to write that down. Okay? And what we learned in this rule is that when you have a log of to an exponent, it's like an exponent to an exponent, and we can bring the p or the power down. Okay, so we're going to go ahead and rewrite this as p times log base b of x. Okay, well, how's that going to help me? Well, if I want to get the exponent down, I just take the log of both sides. Now, I got to be careful. The log I'm going to use is going to be the calculated log, right? So I can use my calculator. Okay, I'm going to use base 10 or base e. So if I take the log of both sides, log of 3 to the x plus 2 equals log of 7, right? Just take the log of both sides. The whole point of doing this is then we can float our exponent down. So we're going to bring the exponent down because you've got an exponent to an exponent. That comes down. You get then parentheses x plus 2 times log of 3 equals log of 7. Now log of 3 is just a number in my calculator. It's just an actual number. I don't know what it is. It's about a point something or other. And log of 7 is just a number in my calculator. So I'm just going to divide. It's like I would solve for anything. So if I divide by log 3, divide by log 3, I will use my calculator. That'll cancel. I'm left with x plus 2 equals, well, what is log 7 divided by log 3? Well, let's let the calculator do that work, okay? I'm going to go log 7, close the parentheses, divided by log 3, close the parentheses, and I get an answer about 1.77. Right, and then just subtract 2. Minus 2, minus 2, and I get an answer about negative 0.228. Negative 0.228. Okay? So the easiest way to solve for exponents is take the log of it and it brings it down. We could have done a the same way. I could have taken the log of both sides, but what I recognize on a is I could make them the same base. Okay? Alright, c. Before I do c, let's write in this little column that the natural log of e is always equal to 1. Okay, write that down in the column. ln, okay, ln of e, the natural log of e is always 1. So whenever I see the number e, I want to use the natural log button. I don't want to use the log button. I want to use this one right here, ln, okay? Because ln of e, in fact, I'll show you, ln of e is 1. I didn't lie to you. What do you know? ln of e is 1, okay? So if I'm going to solve c, let's first, though, just undo. Let's just do some regular math. Divide by 8, divide by 8, okay? And what is 20 divided by 8? Well, it is 2.5. So I've got an e to the 2x. I said e, and I wrote 2. E to the 2x equals 2.5. And now, again, if you want to bring the exponent down, take the log of it. I'm going to say that again. If you need to bring the exponent down, take the log of it. So instead of regular log, though, because it's an e, I'm going to take the natural log. So I'm going to go ln of e to the 2x equals ln of 2.5. Okay, what does that do? It brings the exponent down. So the exponent comes down, okay? Then I'm running out of room, but I'll squeeze in this. So then I have a 2x ln of e equals, I don't know, what's ln of 2? 0.5. I might leave this in my calculator for accuracy, so equals ln of 2.5. And if you want to figure out what that is, you can go, okay, what's ln of 2.5? It's about a 0.916. But I'm going to wait just for accuracy. Okay, now this ln of e is 1, right? It's just 1. We saw that right here, ln of e is 1. So I'm going to kind of cross it out because it's 1 and 2x times 1 is 2x, right? And then the last step, just divide by 2, x is equal to ln of 2.5 divided by 2. And so, you know, for accuracy, I'm just going to use my calculator. Okay, what is ln? Clear. ln 2.5, oh, come on. ln 2.5 divided by 2, and I get an answer of about 0.46, okay? X is approximately equal to 0.46, okay? Alright, D. I'm running out of room, but D is a little bit harder, so I'll do D here, okay? We'll squeeze D in over here. Alright, e to the 2x minus e to the x minus 6 equals 0. Okay, now, looks to me like a factoring problem. It does. Looks like I'm going to factor. So, real quick, what are the multiples of negative 6 that make a negative 1?
2 and 3.
Yeah, how about a negative 3, positive 2, okay? So when I factor this, instead of x's, it's going to be e's, okay? I'm going to go e minus 3, e to the x minus 3, e to the x plus 2 equals 0, okay? Yeah, Nikolai.
Why did you make it LE to the x instead of just e to the x in the problem?
This problem?
Yeah, that problem.
Minus LE.
Minus LE.
I don't see
Right
LE.
there it says minus e for D.
Go up and to the right. There you go.
That's a 1.
That's a D with a
Oh no, D like but the actual problem.
That's
Apparently it's a 1 according to them.
e to the 2x.
Oh wow.
Oh, I put a 1. Oh, I put a 1 here. That's just the number 1.
You should
Oh. Okay.
Gotcha. That's the number 1. Okay, gotcha. Yeah, and that's all it is. I put a 1 here to help. In fact, Paige is totally right. Paige knows me. I put the 1 here to help you factor. Okay. Does that make sense? I wanted the 1 so you guys can see the factoring. Now, I was hoping somebody would say, well, wait a minute, Mr. Davies, how can e to the x times e to the x be e to the 2x?
Science.
Oh, that's easy.
Why is that easy? Why is e to the x times e to the x e to the 2x?
Because you're adding your exponents because you're multiplying them.
Nice job. Jose, genius of the day. Hey, and I got it on film, too.
They can hear.
You're totally right. E to the x times e to the x, when you multiply, you add exponents. Nice job. So now we're not done. We got e to the x minus 3 equals 0. E to the x plus 2 equals 0, right? We're just going to solve. We're going to go e to the x equals 3, right? E to the x equals negative 2. I mean, this should make a little bit of sense, right? Now, what do I do next?
Divide by.
I can't divide by x. It doesn't work that way.
Down.
Yeah, how do I bring it down?
Do log x.
How about we go ln of 3 equals x. And yes, we brought it down. ln is base e, right? And I'll do the same thing here. I'll go ln of negative 2 equals x, right? Now, before I even push any buttons, this is going to be an error. You cannot take the logs of negative numbers. You can't. Question is why? Well, something to any power, doesn't matter what power, will never be negative. Any number to any power will never be negative.
Negative 1.
Well, it's going to just give you like a 1/2 or whatever.
It's a negative 1 to the first.
So I mean, think about 10. 10 to what power? Negative number, okay? Can you put any number in here that's going to make that negative?
I win.
Wouldn't an odd one be?
It won't. It just makes it a fraction, right?
With a calculator.
Just makes it a fraction. Not only that, but you know, if try it in your calculator, trick ln of negative 2, ln negative 2, and your calculator is going to freak out. Check it out. What is it like? It doesn't like that. Non-real answer, okay?
I got it right.
So throw that away. And ln of 3 is a great answer if you want the decimal of ln of 3. I like just ln of 3, but if you want to go, what is ln of 3? It is about 1.098 blah, 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 okay? right, now, that was a hard one, wasn't it? But we're in pre-calc. We're mathematicians. We can do hard ones.
Oh, there's another one.
I thought we were
Let's do E. Okay. Now, if I look at E again, I want to make a hint. How about factoring? How about factor? Okay, when I take a look at E, what do you see that can be factored? Jose, guys, what do you see that can be factored?
An X or an E.
Actually, both right. How about an X and an E to the X? You're both right. Okay, that would leave a 3 plus X equals 0, right? You guys agree with that?
I don't disagree.
So then I'm going to have an X, E to the X equals 0, and a 3 plus X equals 0, right? Which means I also have a possibility of 3 answers. I could have X equals 0. I could have an E to the X equals 0, and I've got that one, and I've got that one, right? Because I just set that equals 0. So 1, X equals 0, that's an answer. Boom, I like that answer, that's true. If X is 0, okay, no problem, we'll get an answer. E to the X equals 0, can't happen.
You can take a log over
Yeah, try it. Try ln of 0. It won't work. For the same reason. No matter what exponent you put up here, it's never going to equal 0. It will never equal 0. You guys agree with that?
Oh, it says
0?
I got
Then
an
try
exponent equal a negative.
Is that error?
It said error, didn't it? So you're never going to get an answer of 0. No matter what you put up here, you'd have to put negative infinity to get 0. Can't happen. Not in this world. Okay?
If there was like another world in like a parallel universe
Maybe.
where like they all had infinity
Yep.
and like they couldn't have regular numbers.
Infinity is
they
just
could
an
have
idea.
Go back and watch Interstellar. There's a whole lot about this and infinity and Interstellar, okay? X equals negative 3. You guys agree with that? So there's my answer. Nothing? Okay, turn the page. Interstellar would be a great one to watch. Going, turning. Yes. X can be, right? X can be negative 3. Okay, turn the page. All right, now, now we're going to solve log equations, all right? The big key to log equations is being able to shift it from log form. Write this down. If I have log base b of an answer equals an exponent, we can shift that into exponential form. We can rewrite this as some base to the exponent equals the answer, okay? So the key to doing log is being able to shift it from log form into an exponential form, okay? So right off the bat, number 2, I'm going to get rid of this log just by going 2 to the 3. I'm just going to go 2 to the third power equals 25 minus x, okay? 2 to the third power equals what's inside, okay? So I just changed it from log form into exponential form. 2/3 8, all right? I'm going to bring over it. I'm going to get a negative 17 equals a negative x, or x equals 17. Okay. Now you need to check your answers, and in this answer it's going to be fine because you cannot take right on your side little thing log of 0. Okay, what's log of 0?
ERROR.
You can't do that, right? And log of a negative number. That's not hashtag, by the way.
Negative hashtag.
You can't do that either, okay? But 17 plugged back in here, we're okay, right? Put 17 up here, we'll have 25 minus 17. We're okay, that will work. Okay, B.
What would you put when you get a
No solution.
like a 0? You just put
No solution, yeah. Okay, or 0 slash through it. Okay, B. Let's solve for B, okay? Minus 4, right? I got a 3 log of 2x equals 12, right? Divide by 3, right? Log 2x equals 4, right? Now, I want to change it from log form to exponential form, but what's the base?
So is it 1?
No, 10. I'm glad you're sitting up front today. Okay, so it's going to be 10 to the 4, right? equals 2x, right? What's that, 10,000? Equals 2x, right? Divide by 2, what's that, 5,000? Okay. Am I going too fast or am I okay?
You're good.
Okay. All right, because this is just basically solving, okay? All right, now, C. C is actually pretty easy. Now, you got to think about it. Let's first of all combine these two.
Can we say it's x to the 1?
We can go log. So when we add exponents, that means that we multiplied their bases. When we add exponents, it means we would have multiplied their bases. Okay? So now it's log of this equal log of that. Now, technically, you're supposed to take everything to the 10 power, 10 to the power of that, 10 to the power of that, but we're going to just be smart and go, whatever's here, actually, let me make sure I do this, because it's log of both of those, right? It's log of the whole thing. So, in this sense, this expression must be equal to 8. Must be, right? So I'm just going to cancel out the logs. You okay with that? I can show you mathematically why that works, but does that make sense? So then I'm going to have x plus 2 times an x equals 8, right? Oh, looks like algebra to me.
Foil it.
Yeah, I got an x squared plus a 2x, and I'm going to bring over the 8.
Wax paper.
Wait,
Okay,
what?
I am. Why would I bring over the 8?
So you can equal 0.
It is equal to 0. Why would I want? What am I going to do next?
Factor.
Yes, I'm going to factor it, right? So how am I going to factor this?
Plus 4 minus 2.
Okay, plus 4 minus 2. You guys agree?
Equals 0.
X plus 4 equals 0. X minus 2 equals 0, right? X equals negative 4 and x equals 2. Except I'm going to throw out the negative 4. Because we had talked how you can't. If x was negative 4, right? If x was negative 4 and I took the negative 4 and put it back into here, I'd have log of negative 4.
I wonder what happens if you ask Siri what the log of negative
We could ask Siri later. Throw that out, and there's my only answer, okay? All right, now, D. Almost done. So, again, what I want to do is bring it together as a single logarithm, okay? So I got log of this plus log of this. Here's what we've learned, that if you add exponents, because these are exponents, it came from multiplying their bases, right? So let's rewrite it as log of x plus 2 times x minus 1 equals 1. I'm going to put brackets around there so you know that's log of that entire thing, okay? Now, I need to get rid of the log because I really can't solve for the log, but I can change it. I can change it to exponential form, but I need a base. What's my base? 10. So I got a base 10 because if it's common log, it's base 10. And now here's what I'm going to do. 10 to the 1 equals what's inside. 10 to the 1 power equals what's inside equals the answer. So go 10 to the 1 equals x plus 2, x minus 1. Okay? Let's FOIL. First, outside, inside, last.
X squared.
X squared minus a 1x plus a 2x minus 2 equals 10, right? Equals 10. 10 to the 1, 10, right? 10 is equal to x squared plus 1x minus 2, right? Bring over the 10. If I subtract the 10, I'll have 0 equals x squared plus a 1x minus a 12. Factor. Am I going too fast or am I okay?
Perfect.
Okay.
That's just my opinion.
Okay. What are my multiples of 12? Negative 12 that make a positive 1? Positive 4, negative 3, right? So we're going to have x plus 4 equals 0, x minus 3 equals 0. X equals negative 4, not really. And x equals 3, yes, really. So I'm going to throw away the negative 4. You guys agree with that? Take the negative 4, and if I plug it back up into here, we'll get a log of a negative value. 3 is okay, so we'll keep the 3. All right?
I don't understand it.